Hi, my name is Thea Yeager-Leonard. I'm an energy analyst in the Office of Sustainability and Innovations. I'll be presenting a brief overview of our community's greenhouse gas inventory. I'll go over the long-term trends of our community's emissions, what we currently account for, and our planned improvements in the future. The greenhouse gas inventory is especially important for our H20 plan because it provides a consistent system to measure our progress. Our greenhouse gas inventory accounts for, at a minimum, the basic reporting categories required by the Carbon Disclosure Project, which we participate in on an annual basis. For the most part, we can't directly measure our largest greenhouse gas emission sources, so the data presented here is based on aggregated, scaled, or modeled data. Our goal is to achieve a 5% accuracy. Additionally, some data is not available on an annual basis, so expected changes may not appear between individual years. As with any analysis, it's important we track the quality of data used and continue to consider additional metrics as needed. Emissions for each source were estimated with methodologies from the ICLEI US Community Protocol, which provides data sources and strategies specific to the US. This is a commonly used protocol which allows our inventory to be compared to that of other cities and provides consistency to observe long-term trends. The Global Protocol for Community Scale Greenhouse Gas Emission Inventories is used for data reported to the Carbon Disclosure Project. The inventory accounts for 3 greenhouse gases: carbon dioxide, methane, and nitrous oxide. Other greenhouse gases, like those used for refrigerants, may be estimated in later years. We can take a look at how our community-wide greenhouse gas emissions have trended since 2000, which is our baseline year. This graph looks at the simple inventory. It includes emissions associated with residential, commercial, and university buildings, our local transportation, and landfill waste. We see that we've reached a 20% reduction in emissions over the past 20 years. We can also look at an average change over the past few years, recognizing that annual weather fluctuations impact emissions. We've achieved an average of 60% reduction over the last 3 years. Many of those reductions occurred in commercial and institutional buildings. This slide breaks out changes in emissions by sector from 2000 to 2019. Because of changes in building categories over the last 20 years between commercial and university buildings, those sectors have been combined to observe their aggregate change. We can see that buildings account for roughly 3/4 of emission reductions to date. Even in cases where total consumption of energy has increased, emissions themselves have decreased due to a cleaner electricity grid. We can see why the grid that provides our community electricity determines so much of our emissions. Our buildings account for 2/3 of our community's greenhouse gas emissions, which primarily consume electricity and natural gas. We can see that the portion of electricity supplied by coal, the dark blue on this graph, has decreased, but it's still a primary source. We can see how big of an impact displacing coal has had on our emissions to date, but how much more work needs to be done to achieve a renewable grid. And we can see how large of an impact that would have on achieving our goal of carbon neutrality by 2030. Ann Arbor has grown and changed in the last 20 years. Comparing changes in population and GDP to emissions, we see that emission reductions are not mutually exclusive with healthy growth. We just looked at a simple inventory to understand long-term trends. Standard protocols for estimating inventories have become more comprehensive and more data is easily accessible. Over the last few years, the inventory is also able to include additional sources of emissions to provide a more complete picture of our carbon footprint. We call this the expanded inventory. In addition to the emission sources analyzed in the simple inventory, it also looks at emissions associated with commuting patterns, local rail operations, and more municipal facilities like the airport and closed landfill, as well as upstream emissions associated with electricity and fossil fuels. While most of the changes are small compared to total emissions, commuting adds around 13% more emissions. These emissions also occurred in previous years as well. We just don't have specific data to accurately estimate their magnitude. The blue line here shows the simple inventory trend shown earlier. The orange line shows the increase in the expanded inventory, largely due to the ability to account for the full range of our commuting. While emissions have decreased 20%, roughly 1% a year since 2000, due to a cleaner grid, we can see that we have a lot of work to reach carbon neutrality by 2030 and have to work at a much more rapid pace. This slide illustrates where our community's emissions come from. We know buildings account for roughly 2/3 of our community's emissions, with passenger vehicles accounting for over a quarter of emissions. The remainder is accounted to commercial vehicles, waste, and upstream emissions. The left graph illustrates year-to-year changes in emissions by sector, with the top values representing the total emissions each year. There are some changes from year to year. This is mostly due to changes in consumption in electricity and natural gas that are weather dependent. We can also put the expanded inventory in the context of population changes. This slide illustrates emission trends per capita. Per capita emissions have decreased faster than total emissions, meaning that as we grow, each Ann Arbor resident has a smaller greenhouse gas footprint. This slide illustrates the source of our community's emissions. The use of electricity represents the most emissions in 2019. This portion of the emissions is expected to continue to decrease as planned changes from DTE and the University of Michigan come online and more coal is phased out. However, a natural gas-powered grid will still have significant greenhouse gas emissions associated with it. The A20 plan targets securing 100% renewable energy for our community to eliminate emissions associated with our electricity consumption. We see that the natural gas and fuels used for transportation will become the largest sources of emissions, highlighting the importance of transitioning to sources of energy whose emissions can be decreased. This really helps illustrate how the strategies in A20 are informed by our community's greenhouse gas emission inventory. In the beginning of this presentation, I went through our simple inventory, which allows for evaluating the long-term progress compared to a 2000 baseline. Then we looked at an expanded inventory, which provides a more comprehensive picture of where we are now. In the future, we hope to share an expanded plus inventory, which will include consumption-based emissions, like the expanded transportation activities, how we consume food, goods, and services, the embodied carbon in our buildings and new construction, and renewable energy credits and offsets. We plan to develop this inventory as part of a cohort organized by ICLEI, which was postponed due to the COVID-19 pandemic. This was a brief overview of our greenhouse gas inventory. For more information, visit our department website for annual reports, guides, and calculations. Thank you.